Alright, today's example will be covering a linear systems cost equation or equations. So again, just to recap, the steps for solving any type of problem. So step one is to identify our unknowns and our knowns. We want to identify what it's asking us for, and we want to identify what we already know. So I'm going to go ahead and read the problem. Over the weekend, Nevaeh's family rushed to Luxury Cinema to see summer blockbuster Rogue One. All tickets were sold at the box office. Student tickets cost $18, and that should probably say dollars each, and adult tickets cost $23 each. Luxury Cinema sold 21 tickets and collected a revenue of $388. The first question asks us for how many student tickets were sold, and the second question asks us for how many adult tickets were sold. So the two things that we don't know, or that we know that we don't know, are the two things it just asked us. How many student tickets were sold? So we don't know the number of student tickets sold, and we don't know the number of adult tickets sold. When we don't know something in math, we use variables to represent them. So we're going to take the context and we're going to put it into algebra. So I'm taking number of student tickets sold, and I'm going to say that's what X represents, and the number of adult tickets sold is going to be what Y represents. Now let's go back through and identify the things that we know. And again, the things that we know are our values. So over the weekend, Nevaeh's family rushed to Luxury Cinema to see the summer blockbuster Rogue One. All tickets were sold at the box office. Student tickets cost $18 each. And adult tickets cost $23 each. Luxury Cinema sold 21 tickets. And collected a revenue of $388. So you can see I've highlighted some things that are related to student tickets, some things related to adult tickets, and then I underline in red things that are related to tickets, and in blue things that are related to money. I'm going to go back through. This is related to money. This is related to money. Okay? So we've got three things in blue, one thing in red, and two things are highlighted. So what do we know? We know that student tickets, or we know that X, sorry, I should use black. We know that X is $18 each. So X isn't 18, but we know that X is going to get multiplied to 18 because 18 is the rate for a student ticket and X represents the number of student tickets. We know that Y is going to get multiplied to $23 because that's the cost for each adult ticket. We know that 21 tickets were sold, applying that's a total. This is a total. And we know that the theater raised $388. So we know, again, a total rev of 388. So step two is the model. Determine what model and then set up a plan for solving. So step two, we've got two models. We've got y equals mx plus b versus we've got ax plus by equals c. Now just to recap, A and B are rates, and C is a known cost. Not cost, sorry, total. So when we look at what we have over here, we've got some rates. We've got some rates. 18 each, 23 each, and we got a cost or a total. We got total and we've got a total. So we're going to use standard form. So let's go ahead and set this situation up so that we can solve. So linear systems, we know that we're going to have two equations. So we have equation 1 and we have equation 2. I'm going to identify what these equations represent based on the information I'm going to put into them. So equation 1, when I look at all the things that I know, I see I've got some cost things that I know, and I know the total cost. So I've got 3 things that I know that are related to cost. So I'm going to make equation 1 total cost equation. And the total cost equation would be the cost for a student ticket, which is $18, times the number of student tickets, plus the cost for an adult ticket times the number of adult tickets, equaling $388. The other equation has to do with number of tickets or tickets. So we got tickets, we got tickets, and we got tickets. We got 3 things again. So we can say this is a total ticket equation. So we know that our total tickets sold was 21. What we don't know is how many student tickets were sold, and we don't know how many adult tickets were sold. But we know that when we add those 2 totals up, those 2 individual totals up, that they're going to have to equal the total number of tickets, which is 21. So now that I've got the 2 equations, all I'm going to do here is graph. So I'm going to open up the graphing calculator, and I'm going to type those 2 equations in to figure out what x and y are. So our cost equation, we've got 18x plus 23y equals 388. And for our total tickets, we've got x plus y equals 23. So you can see I've graphed both of these. And now I'm just looking for where the 2 lines intersect. So they intersect down here, which is clearly not correct because we can't have a negative value. So I've done something wrong. Let me go back to see what I've done wrong. 18x plus 20y equals 388, and x plus y equals 21, not 23. And that changes my answer significantly. So now you can see that the intersection, so we've got number of student tickets is our x, number of adult tickets is our y, and where they intersect is 19 for number of student tickets and 2 for number of adult tickets. So that was step 3. Step 3, we used the graphing calculator to solve, to execute our plan. And we got x equals 19, and we got y equals 2. Step 4 is to put them back into context. So we're not talking about x and y, we're talking about how many student tickets were sold. Well, we know that it's 19. How do I know that? Because we made x student tickets. How many adult tickets were sold? That's y. The y value that we got was 2. Okay, now I'm going to just draw a little line right here so that we can answer questions 3 through 5. Okay, so it says, assuming the total number of tickets remains the same, how much would the theater profit if they sold each ticket for the same price of a student ticket? So assuming the total number of tickets remains the same, so we know that the total number of tickets was 21. If they sold each ticket for the cost of a student ticket, how much would they have made? Well, times how much it costs for a student ticket, which again is 18. All we're doing here is we're multiplying 21 by 18. So 21 times 18 is 378. So they would make 378, or $378. How much would the theater profit if they sold each ticket for the price of an adult ticket? So 21 tickets total. The price of an adult ticket was 23. And that would, so if they sold each adult ticket for 21 total tickets, then they would have made $483. The last question says, how much more revenue would luxury cinema bring in by selling adult tickets? So how much more is applying, how much more would they have brought in if they sold adult tickets versus student tickets? Well, so we have to take the 2 totals, total for if they sold all the tickets for adults, and subtract that to figure out how much more they would have made if they sold all the tickets for students. Doing so, we get 105. the theater or luxury cinema would have made $105 more if they would have sold the tickets for the adult price rather than the student price.